0.1 meter is placed as shown in the figure, where in this region the electric field is 500 x exist, where x is in meter and electric field is in newton per coulomb. They have to first find the electric flux passing through the cube and the charge within the cube. So here, given that the electric field intensity is 500 x, this means that the electric field intensity varies as the distance along the x axis is changing. And it is also mentioned that the side of the cube is 0.1 meter, and the given other given data is electric field is 500 x. Let me collect the data first here. So it is given that the side, let me take the side as x is equal to 0.1 meter, and you should also observe another point, that the cube is placed at a distance of 0.1 meter from the origin along the x axis. Okay, so we know that the electric flux exists along this face of the cube. Let me call the electric flux along this side, I call it as phi L, and also electric flux along this side of this face of the cube, I'll call it as phi R. The net electric flux is because of the flux along the left side and the flux along the right side. So first let me find electric flux along the left side. Electric flux along the left side, I'll call it as phi L. Phi L is equal to, we know that phi L is equal to E dot A. Okay, so E dot A as can be written as EA cos theta. EA cos theta. So what is theta? What is the angle between electric field and your area of the cube here? It is 180 degrees. So EA cos 180 degrees. So I get electric flux along the left side as minus EA. Why did I get minus? Is because cos 180 is minus 1. Similarly, okay, so going on further, I'll substitute the value of electric field. We know that electric field is given in the question here as 500 x. So E is what? The magnitude of electric field intensity is 500 x. So x is 0.1 times, this is 0.1 times the area of the cube here, area of this side of the cube here is 0.1 whole square. So 0.1 whole square, area is side into side. Solving this, I get phi L, the electric flux along the left side, is minus 0.5 Newton meter square per coulomb. So this is the electric flux along the left side. Similarly, I will also have to calculate the electric flux along the right side. So electric flux, I'll use the same formula, phi L is phi R. So this is the electric flux along the right side. Phi L is equal to what? E dot A. So right side is what? E dot A. What is the angle between the electric field and the area vector? Here is 0 degrees. So I get EA cos 0 degree. So EA cos 0 is what? Cos 0 is what? 1. So EA times 1 here. EA times 1 is EA itself. So what do I get? What is the value of electric field here? The magnitude of electric field is 500 x. So x is 0.1, because it's given in the question. Electric field is 500 x, and the area of the side of the cube is what? 0.1 whole square. Solving this, phi R is equal to, what do I get here is, here while solving I get 1 Newton meter square per coulomb. So this is what the electric flux along the right side. Our intention is to find the net electric flux. Net electric flux phi is equal to phi L plus phi R. So I get phi L. How much did I get? I got 0.5, that is minus 0.5, that is in the opposite direction, plus phi R. Phi R I got 1. So the net electric flux is equal to 0.5 Newton meter square per coulomb. So we have answered the first part of the question here. So the electric flux passing through the cube. And the second part of the question, the charge within the cube. We also have to find the charge within enclosed by the cube here within the cube. So I use Gauss law here. Gauss law states me that phi is equal to q by epsilon naught. So our intention is to find q here. We know the value of phi. We already know the value of epsilon naught. Epsilon naught is a constant here. Substituting that, q is equal to phi times epsilon naught. On solving this, I get q is equal to 4.4 into 10 power minus 12 coulomb. So this is a solution for the second question.